During this video, we are going to spend time discussing the difference between kinetic and potential energy, along with practicing how to calculate each. We will also discuss other forms of energy. The goal is to use our knowledge of energy to better understand how energy changes from one form to another. This lecture will be broken down into two parts. The first video discusses kinetic and potential energy and how to calculate all the variables of each type of energy. Before we can talk about different forms of energy, we first must understand what energy is. Energy is the ability to cause change. Also, if an object can change its surroundings or itself, it has energy. For example, the sun creates a lot of energy. That energy from the sun changes objects around the sun. That energy causes the temperature here on Earth to change. It causes the weather here on Earth to change. It even causes your skin to change when you get a sunburn. If you think about it, if you did not have any energy, it would be very difficult to do anything or change anything. The definition of kinetic energy is energy due to the motion of an object. Anything that is moving has kinetic energy. A car driving down the road, a person snowboarding, someone running. Everything that is moving has kinetic energy. Your body has kinetic energy all the time, even when you're sleeping. Your heart is continuously moving, so it also has kinetic energy. Another way to remember kinetic energy comes from video games. A while back, Xbox came out with a new way to play their video games, using something called the Kinect. They spell Kinect using the first part of kinetic energy. Why? Well, you have to use kinetic energy in order to play those games. What is nice about kinetic energy is you can actually calculate how much kinetic energy something has. You just need to know a few things about that object. Hopefully it's pretty obvious that if we're calculating kinetic energy, which is the energy due to motion, you need to know how fast the object is moving. We're going to call that velocity, which is measured in meters per second. The other important variable to know is the mass of the object. Mass is measured in kilograms. The last variable in this problem is energy, which is measured in something called joules. Now, we need to know the formula for kinetic energy in order to practice. So, first let's figure out, in this problem, what we already know. We're dealing with a jogger. That jogger has a mass of 60 kilograms and is moving forward, so that's our speed, at 3 meters per second. What you need to do is calculate the kinetic energy of the jogger. So pause the video, see if you get the right answer. In your calculator, you should have taken 1/2 times the mass, which is 60. Multiply that by 3 squared, and you should have gotten 270 joules of energy. So hopefully you got that right. If you didn't, double check your calculator, double check your math. We'll be doing more of this in the future. Another type of energy is potential energy. Now, potential energy is a broad, general type of energy. There are 3 specific types of potential energy: gravitational potential energy, chemical potential energy, and elastic potential energy. Each of those examples is a type of potential energy because energy is stored inside objects and then has the potential to change into a different kind of energy, like kinetic energy. Let's start with gravitational potential energy. Hopefully you have figured out that gravitational potential energy has something to do with gravity. In this case, the energy comes from the gravitational attraction between 2 or more objects. So, what is gravity? Well, it is the attractive force between objects that have mass. Pretty much anything has mass, so anything has gravity, and then therefore also has some sort of gravitational potential energy. For an example, an apple hanging on a branch has gravitational potential energy because both the apple and the earth have gravity and are therefore attracted to one another. The device you are watching this video has gravitational potential energy between the device and the earth as well. Let's think about this though. What makes something have more or less gravitational potential energy? To answer that question, we need a formula. In this formula, we need to know the mass of the object, again, measured in kilograms, how far above the ground the object is, and we're going to call this the height, and height is measured in meters. And we need to know the pull of gravity. In this case, we are going to call the pull of gravity the acceleration due to gravity, which on Earth is always 9.8 meters per second squared. When you multiply all of those things together, you get the gravitational potential energy. So, let's try this problem. Again, we need to figure out what we already know. So we know the monkey has a mass of 1.2 kilograms. The monkey's hanging above the ground at 6 meters. So far so good, right? Now, do we know the force of gravity? Well, yes. The variable g is always going to be the 9.8 meters per second squared. So, plug those numbers into your calculator, pause the video, and then see if you get the right answer. If you do all that, you take the mass, so 1.2 times 9.8 times the height, in this case is 6, multiply all those things together, you should get 70.56, and then don't forget your units, which in this case is joules. So if you didn't get that right, double check your math, make sure you're plugging everything into the right spots. For these questions, read the statement and just determine which formula you would use to get the right answer. You don't need to calculate it, just choose the right formula. Pause the video, write your answers down. When you're ready, check your answers. So in the first example, the Great Dane is moving, so you should have used the kinetic energy formula. In number 2, the bird is just sitting above the ground, so you should have picked the potential energy formula. And for the third one, skydiver falling, reaching a speed, and then jumping from a height of 39,000 meters, you actually could have picked both and calculated both. Now, this example is a little bit different. So first, let's figure out what we already know. In this case, we have an apple. It's hanging, so that should tell us that we need the gravitational potential energy formula. The apple is 25 meters off the ground. Now it's on Earth, so we know that our g is going to equal 9.8 meters per second squared. But in this formula, which is a little bit different, they give us the potential energy of 100 joules. So what don't we know? Well, we don't know the mass of the apple. So we need to do things a little bit differently. Here's our formula down here, right? We need to get mass all by itself. So what I'm going to do is I'm going to take this stuff over here and put it over by my energy. To do that, I'm going to take 100 and I'm going to divide it by 9.8 times 25. So try to do all that in your calculator and see if you can figure out what the mass of the apple is. When you're ready, start the video back up. So in this case, when you do all of that math, the mass of the apple is going to be equal to 0.4 kilograms. Another type of potential energy is the energy stored in ionic and covalent bonds. Think about all of the food you eat. Besides eating food because it tastes so good, what's the whole point of eating? Well, it's to get energy. But where is that energy coming from? Well, it's in the chemical bonds that are in your food. When your body breaks those bonds, that energy is then released and you can use all of that energy. Other materials that have chemical potential energy are fossil fuels like coal, oil, natural gas, things like that. If you ever stretched a rubber band or bungee cord, you have felt elastic potential energy. Anytime an object is compressed or stretched, that energy is stored up in that object, which then can be released at a later time and usually comes out in the form of kinetic. Now, a rubber band just sitting on a table or on a desk not being stretched or compressed does not have elastic potential energy. However, once that rubber band is stretched, then it does have elastic potential energy. One last check. Take a look at the 4 examples and determine what type of energy can be found in each. Pause the video, write your answers, and then check if you got them right. In picture 1, you should have picked elastic potential energy. In picture 2, you should have chosen chemical potential energy. In picture 3, both kinetic and potential energy are in the picture. And for picture number 4, you should have just chosen potential energy. Watch this video as many times as you need. Go back and check out the things that you need.